you have a squared over the a to the fourth, you can write it as a times a, and on the bottom it'd be a times a times a times a. Two of these a's will cancel out, leaving 1 over a to the second. If you take our shortcut and subtract, 2 take away 4 is a to the negative second. So a to the negative second power or 1 over a squared are the same thing. In the second problem, you reduce by dividing both by 5. You would have 1 over 3, because 5 will go into 5 one time, 5 will go into 15 3 times. We're going to put 1s where there are no exponents. Subtract, taking our shortcut, a to the third, 3 minus 1 is a to the second. And 1 minus 4 is b to the third. And because 4 from 1 is a negative 3, it would go on the bottom. Or you could write 1/3 a to the positive second. Because the b is on the bottom, you would put b to the negative third. Anything on the bottom has a negative exponent. If you look at the third problem, x to the fourth over x to the negative third, you would subtract the exponents. 4 minus a negative 3 turns into 4 plus 3 because of the double negative, which is 7. So therefore the answer is x to the 7th. Or you can just remember anything with a negative exponent will go on the top. If the negative exponent's on the top, it would go to the bottom. So all you would have to do is just write it as x to the fourth times x to the third, which is x to the 7th. Anything with a negative exponent just gets switched. If we had x to the negative fourth over x to the third, you could take the 4, x to the fourth, and put it on the bottom. And we would have 1 over x to the 7th. And again, if you took the shortcut and subtracted negative 4 minus 3, you would get negative 7, which is x to the negative 7th. Same thing as 1 over x to the 7th.